You asked what would it take for these plants to convert, and I think what it takes is a price on carbon. Once you take the new natural gas step out of it, because you're trying to reduce your CO2 emissions, you have to make do with what you currently have on the system. And that's what we're really talking about here. How can we still provide a reliable electric grid that includes fuel diversity and that includes coal to some extent, but making it neutral in some shape or form.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about the future of our coal fleet. Based on data I pulled, there are 337 coal-fired units producing energy across the United States. They're not all utility scale, but together they produce 171 million megawatt hours and can't be replaced overnight. For this episode, I had the opportunity to assemble a panel to discuss the future of coal-fired generation. To make it simple for the audience, I had my three panelists present three options. The first is carbon capture. Eliminate the CO2 from coal exhaust and combined with modern emissions controls, just about the only thing coming out of the stack is steam. This captured CO2 can be injected into oil wells to enhance oil recovery, and yes, the CO2 stays down there. You can also sell the CO2 to make chemicals, but that has its limits. Another option is to sequester CO2 underground permanently. There are no market-based financial incentives for this. Instead, the government offers a tax credit of about $50 a ton under a scheme called 45Q. My second panelist says coal can take on a new role as a supporting player, kind of like the star quarterback who's now second string. Coal plants have traditionally been baseload power. Like nuclear plants, they run most efficiently and cleanly when they're running full out. But in the last 12 years, as my guest points out, nearly half the available coal fleet may be offline at any time. These assets essentially take the field only when demand absolutely requires it. My guest has been advising utilities and operators on ways to make coal plants effective at backing up renewable generation, for instance. This is a level of flexibility most coal plants were never designed for, but may now be necessary for them to operate at all. And finally, it may be time to say so long to coal altogether. Just like my guest in episode 110, several coal plants are being repowered to run on gas, biomass, or a combination with coal. The good news is that the facility continues to operate, the employees still have their jobs, and in many cases, the existing coal boiler and steam turbines can remain intact. Like my guests discuss, it's important that we have a diversity of options to call upon to meet our energy needs. Those Texas outages earlier this year showed that coal still has a role to play when we need it most. It's very possible that coal, used responsibly, could get a second life in our energy mix. My panelists today are Philip Grader from Energy Ventures Analysis, Gary King from Black & Veatch, and Jared Thomas from Mitsubishi Heavy Industries. They represent the load following, retrofit, and carbon capture issues, respectively. These guests were part of a panel I hosted for the PowerGen Plus virtual series. It was important for me that we explore all available options for coal. One of the points I've made repeatedly on this podcast is the importance of exploring ways to address the negative issues of any energy source. Coal gets more grief than any, so it's fun to counter program against the prevailing wisdom. And I think you'll find that there are several ideas in here worth pursuing. I hope you enjoy my panel, Converting a Coal-Fired Plant, Benefits and Challenges, from the PowerGen Plus series. Good afternoon. It is my privilege to host what I believe will be a very thoughtful panel on the future of our coal fleet. My name is Jay Downhauer, and I'm the host of the EnergyCast podcast, now in its 5th year. And my guiding philosophy has always been the same. Every energy source has a place in our future, and we need to focus in a clear-eyed way about what challenges each of these technologies inherently have, and then try to solve them. I was made executive director of a carbon capture and storage association in Texas about 12 years ago. I wasn't in the role for long. The economy and shifting energy policies forced the group to dissolve, but it was encouraging to see NRG begin a commercial carbon capture facility in Texas in 2017. I want to share something with you very quickly. It's no secret that coal is in decline. Last year marked the first consistent time renewable energy overtook coal. You saw this happen a little in 2019, but on March 25th, 2020, renewables overtook coal daily for 40 straight days, and we can expect to see that pretty regularly. I think there's a future for coal and its legacy plants in there somewhere, but the industry needs to get smarter, and maybe some of the solutions presented today are the answer. So my guests are Jared Thomas, Business Development Manager for the Engineered Systems Division at Mitsubishi Heavy Industries. One of the big things he's going to talk about today is carbon capture. We have Gary King. He's the Senior Vice President and Global Services Leader for Power at Black & Veatch. He'll be talking mainly about coal-to-gas retrofits. And then Philip Grader, Manager of Energy and Environmental Markets for Energy Ventures Analysis. And one of the things we've been hearing about that he's going to discuss is load-following retrofits. So Philip, we're going to start with you first. Tell us what Energy Ventures Analysis is working on and some of your insights.
Thank you. My name is Philip Garrett. I'm a manager here at Energy Ventures Analysis. For those of you who don't know us, we're an energy consulting firm located in the DC metro area and really focusing on a very high level on the supply, demand, and price forecast for all the major energy commodities, be it coal, natural gas, oil, electricity, renewables, and emission allowances. What really brought me to this panel was a white paper that we did for the National Association of Regulated Utility Commissioners, or NARUC, back in 2019 and 2020, where we looked at the hourly operating data of U.S. coal plants in 2008 at the high point of coal generation in the country, and then compared it to operating characteristics in 2018, 2019, and now just for today with 2020 data, and looked at some of these trends and try to come up with some recommendation that utility commissioners should really ask utilities to look into as possible technologies or practices to increase a coal plant's flexibility, reliability, and overall profitability in this new operating world. First chart I wanted to show you, everyone, is the average distribution of utilization rates for coal-fired power plants. Traditionally, coal plants have operated, as you can see, in 2008, 55% of the time operated at capacity factors greater than 80%, which we consider for a traditional base load generation to be the optimal utilization rate. But as you can see, not only coal plants have been more offline over the last few years than in 2008, especially last year, almost half of the time, the average coal plant in the country was offline. More and more coal plants are really only ramping up at significantly fewer times throughout the year. The second, that is also very key in the operating part, is how many starts do they experience over the course of the year, and then categorizing them in terms of hot starts, warm starts, cold starts, and then the long-term outage longer than 5 days here. I think the trend is very obvious here. In 2008, coal plants spent very few days offline, and this really goes mostly to maintenance outages. And this really flip-flopped over the last 10 to 12 years, as you can see. The average outage length in 2020 was over 25 days. And when they came back online, the ambient temperatures of the boiler equipment and everything was also much, much lower. So it put additional stress on the overall plant equipment. Last but not least is the average hourly generation change for these coal-fired generating units. There is a trend towards higher ramp rates, which would suggest what Jay already talked about, the more load following that these coal plants are asked to do now. Very important to put this into perspective as to what that coal plants are asked different jobs in different areas. In Maryland, coal plants are actually asked to do less ramping because it's had a huge shift from coal to natural gas. They're offline for significantly longer periods of time. They usually just come online during very high periods of high demand, and so they're running all out. On the flip side to that, in Kansas, coal generation was mostly displaced by wind generation over the last decade. When very little gas, it's now the role of the coal plants to be the load-following resource and fill the void when wind generation is down. Now, I just want to talk about the different technologies and improvements plant operators can do to increase that flexibility. It's really plant specific, and one thing that works for one plant doesn't work for another. But the key things are obviously increasing the cycling efficiency of these plants, be it through sliding pressure operations or variable speed drives or some type of boiler draft control scheme. And then there's a lot of operational changes that can be made, like establishing and following this new cycle chemistry guidelines for these flexible operations. Again, these chemistry guidelines are very different than from standard baseload, as well as having accurate cycling costs to really ensure that these plants are operating at the optimal time and not actually costing more money than they should, as well as flexible operating studies and aspect on these additional data collection, operator coaching to really help these plant operators understand their plants better for a better operation. Thank you. That's all I had.
Next, we have Gary King, Black and Veatch. How you doing, Gary?
Doing great. Thanks, Jay. All right. So what I'd like to do is to first kind of set the stage on coal plant conversions, because they do come in many shapes and sizes. There are plants that do just a fuel switch, reusing most of the equipment, doing modifications to the burners and to the boiler itself. And some cases, maybe dual fuel where you can still use some coal or bring in some gas. Some customers are looking at fuel switch to biomass. And I know there are a few operating plants today doing that. Then there's what I call partial repower. That's the addition of a simple cycle gas turbine, taking that hot off gas, running it through the wind box and helping with the boiler there. And then getting into the last two boxes, that's more repowering. The first one I'm repowering, really reusing the steam turbine and maybe even some additional equipment that you have. But then there's also a full repower where you're really just reusing the site, maybe maintaining the same air permit, and there may be minimal reuse of some ancillary systems. So that's still a possibility. The benefits and the reasons for doing it vary greatly, from extending the life or getting more output or efficiency, or you may be trying to enhance environmental performance. And we're seeing the need more and more for that, especially in different parts of the world and in the country. Some of these considerations, I would separate these from technical, financial, and non-technical. You're just talking about the technical and the capital involved, the economics behind it. You will be considering fuel costs and volatility of your fuel. What's the dispatch profile going to look like? What's the load profile going to look like? Is it going to be dispatched frequently throughout the day? Is it still meant to be a base load? The age condition of the existing plant or the equipment, if you're trying to reuse any of that, that's very important. The capital cost, if you're bringing in gas, don't forget about the gas pipeline and how close you are to gas infrastructure. And then after the conversion is complete, what's your operation and maintenance costs, ongoing costs? A newer aspect of this is clean energy options. We're seeing many customers that we're helping with thinking through, can you go ahead and add the capability for future hydrogen, future decarbonization, carbon capture? You could put in some of that in place and avoid some future costs. And that helps to future-proof your project. Non-technical, really important to consider these items because we've seen many a project become shelved because not quite considering the local community or considering the environmental and the changing regulations. Those are really important aspects to get on the table up front to help keep the project moving forward. Thank you, Jay.
And then finally, Jared Thomas, Mitsubishi Heavy Industries. How are you doing?
Doing great. Thank you, Jay. As Jay mentioned, my name is Jared Thomas. I'm a business development manager at Mitsubishi Heavy Industries America, and I'm here to talk a little bit about the MHI KMCDR process, which is our post-combustion capture technology, the Kansai Mitsubishi carbon dioxide recovery process. That is what KMCDR stands for. And KMCDR is an amine-based technology. Amine technologies have been around for 100 years. They've been used in the midstream industry for quite a while, but we have some key differentiating points about our technology that makes it specifically applicable to post-combustion. The first of those, and the primary one, is the KS1 solvent. This is a proprietary hindered amine solvent with a high CO2 capacity, low degradation, and low regeneration energy. We also have done quite a bit of work on reducing amine losses from the system, which benefits the operating costs. And then the third item I'd like to cover here, this would be heat integration. So again, back to operating costs, we have done significant work over the past 30 years to minimize the energy consumption of this plant, minimize the heat needed to liberate the CO2 from the solvent. This process is fairly simple. The flue gas comes in, we contact it with the solvent, and then we strip the CO2 from the solvent using heat, right? And so the solvent then circulates back to the absorber and continues in that loop. We've been developing this for over 30 years. We're also capable of capturing 95% of CO2 from combustion gas, even from lower CO2 sources, such as a natural gas combined cycle, which may have 3 or 4 mole percent CO2. And then we produce a greater than 99.9% purity CO2 stream. Now, where is the KMCDR process applicable? It's been applied to a wide variety of flue gases, and it's not just specifically applicable to power generation. We've tested this on natural gas boiler exhaust, oil and coal-fired boiler exhaust, and also a simulated gas turbine exhaust stream. These industrial applications on the right-hand side are by no means comprehensive, but you can see that this technology generally fits into any application that's at a near atmospheric pressure, and temperatures can vary. We can cool the gas before it enters the process, but we prefer to have the temperature closer to around 100 F if possible. Our commercial experience spans the globe. Most of this you'll see is from natural gas furnace for chemical production outside of North America, but in North America, as Jay mentioned, we do have the Petronova project, which is the largest carbon capture and sequestration project in the world at 4776 metric tons per day, and that is used for enhanced oil recovery. And I'll turn it back over to you, Jay. Thank you.
Thank you, Jared. And hey, this is one of the things that sits on my shelf. I was handed this when I was back in Austin working for the Clean Coal Foundation. Jared, I believe we worked this out. This is packing material, right?
Yes, that's right.
We'll start with you, Jared. Pragmatists would tell you that the only viable business model for carbon capture at the moment in the U.S. is to have an oil field partner who can take the captured CO2 and use it for enhanced oil recovery. Essentially, the Petronova model in Houston, they had an oil company they partnered with on that deal. Is there another solution, or is enhanced oil recovery really the first and only?
Well, if you're going to do a carbon capture project at a scale like that, you really have two options. One is enhanced oil recovery, and the other one is sequestration. Of course, the tax credit 45Q now applies to both of those circumstances, where if you're doing enhanced oil recovery, you can get up to $35 per ton of CO2. And sequestration can get up to $50 per ton of CO2. A business model that incorporates either of those makes sense at large scale. When you get down to smaller scales, you may look at some niche applications, such as generating enhanced methanol production, for instance, uses CO2. And CO2 can also be used in the production of fertilizer and many other different products. But again, you have to really consider scale, because as you might be aware, these power generating facilities do output a significant amount of CO2. And so you have to be sure that you're not saturating markets with the product that you ultimately want to make with it, right?
And then, Gary, the biggest challenge for a coal to gas retrofit is the availability of a natural gas pipeline. We discussed this in the last PowerGen panel I hosted. I would assume that top contenders would easily be coal plants with natural gas peakers already on site, correct? You'd just be adding more gas.
Yes, it definitely helps. If you already have access to a gas pipeline, it's going to be a real game changer to making the conversion happen. I mean, there are other challenges, obviously. Some of the things that I mentioned earlier about future-proofing your project and what are the environmental regulations coming in. It just depends also your location and what carbon tax may be coming in. We're seeing that in Canada today, and it's just important to eyes wide open on all potential risks for the project.
Philip, we are considering now making coal power variable and load following renewable energy, for instance. How far away are we from, say, a coal and storage option at these plants? Would that make economic sense in any way?
It potentially could. I think, first of all, coal and whether it's coal inventory is essentially a form of energy storage. You're just storing chemical energy that's stored in the coal on site. And I think, especially this year in Texas and in MISO and SPP, we've seen how invaluable that is when you have these supply disruptions on the natural gas side that you don't necessarily have on coal. In terms of the actual short-term energy storage, what you're referring to as in like batteries and that kind of stuff, it's really interesting to know, actually. Under the previous administration, the National Energy Technology Laboratory, or NETL, actually looked at what would be an optimal new coal plant that was very flexible and that would be made for this new environment. And their prototype essentially had a short-term battery storage, had a simple cycle combustion turbine, and a more traditional ultra supercritical coal unit in there, and to really combine all these advantages that all these new technologies have into one resource. In terms of how far away are we on that, I think right now the communication between the people that are really pushing energy storage are not necessarily the same people that are also talking to coal plant operators. But I think, as you mentioned at the very beginning of our session, I think fuel diversity, as we've seen this winter, is key to trying to maintain our grid stability and reliability. And I think everyone needs to come to the table so that we can have this conversation.
Guys, I'm going to go through as many questions as I can can from the audience, and they're good. First one calls back to the EIA report. It says, the EIA just posted a report showing coal-fired power contributed 25% of the generation mix so far this year. I assume the winter storm outages played some part. Did that storm help make coal's case for its resiliency for on-site supply streams? We saw a lot of back and forth during the Texas situation about, hey, fossil really sung for its dinner in that situation. So any thoughts on that?
I can start since I just already talked about it. For one, I would consider Texas separate from MISO and SPP because in the end, really, we have the same extreme temperature drops all across from North Dakota down to Texas. Texas, as we know, the market is very different. It's essentially what we still have left as the Wild West in terms of power generation. And if you're considering a once in a lifetime or once every 100-year weather event, considering the cost of weatherization of your power plants against that, that's a risk that some utilities or some plant operators just weren't willing to take. So I kind of want to stay separate from that. But I think looked at very detailed into the hourly operation of these coal plants during this weather event, especially in MISO and SPP. And before that, we had very low utilization of these power plants, and they really were able to ramp up and really stay at these high demand levels. And part of what I said earlier, too, about already having coal stored on site. There are some supply chain issues also for the coal plants. Some rail cars were frozen. You had some delivery issues there. But because you have at least 30, 40 days of inventory on site, these coal plants were able to weather the short-term cold weather event, whereas some natural gas plants had to come offline because residential and commercial heating takes precedence over the power sector unless you have a firm delivery contract on that.
Yeah, that's another point we brought up, this idea that Texas was out of the ordinary. And yeah, you can have wind turbines that can be weatherized, but in most cases in Texas, they didn't need to because the weather was just so unusual. We got another question from Derek O'Donnell, and it's an interesting thought here. He says, with coal as a backup to wind, at what percentage of wind capacity would the overall CO2 emissions start to increase? And the justification for this was the more you are operating coal plants at low loads, the more inefficient their operation emits more CO2 per megawatt when compared to baseload operations. So any thoughts on that?
I can't comment on the efficiency of a coal generating unit, but I can comment on it from the perspective of the carbon capture unit. And we've actually looked recently at turndown and intermittent operation. And it's, again, part of an overall NETL effort, as was mentioned previously. Generally, the carbon capture facility, if it's tied to a coal plant that is experiencing a low turndown at high frequency or intermittent operation, our process can respond effectively. So from the standpoint of the carbon capture plant, there are some aspects of the design that should be managed early on. But other than that, it's good from our perspective.
Yeah, I'll just add to it. If you're having that much turndown on a coal facility, the economics obviously are changing on that facility. So that's when we start to get client questions about, well, what if I just reuse my boiler and my steam turbine and I bring in some gas and start to change just the setup and be able to operate more like a peaker efficiently? And you could still add carbon capture to the back end of that. For sure.
Gary, this one might be another one for you. One of the questions we got from the audience was, how much of an impact does the smokestack of a legacy plant play in the decision to convert, replace, or repower? Now, I'd assume that also goes for a lot of the equipment out there, right?
Most definitely. The smokestack itself usually is not a make or break. It's not big in the evaluation. It certainly needs to be looked at. The wind box, if you're reusing equipment, the wind box, the burners, the boiler itself, the steam turbine, and then there's a host of 5 or 6 other ancillary systems that need a deep look at. But I haven't seen a smokestack become a big issue one way or the other. You never know when we come across a new one like that.
Jared, you might have brought this up, but this was a question I always got when I was with the Clean Coal Foundation, was energy penalty, parasitic load. We've had a few questions from the audience. So this is one. What is the energy penalty? And they're asking for specifically your KM-CO2 system.
It depends on how you've designed the unit, right? So you can have these units be designed with an auxiliary boiler to provide their own steam. And so it's not withdrawing steam from the turbine of your generating unit. And so effectively, there's really not an energy penalty per se. However, if you are withdrawing steam that would otherwise be used to generate electricity, it's anywhere in the range from, you look in the literature, 20 to 25%. But the way I always think about it is, if you could extract a fuel from the ground that you could generate power from, and you could do it without producing CO2, and you had to take a 20% hit, you'd still do it, right?
Yeah, and one of the things I wanted to also point out, and this is something you and I talked about before this panel, Jared, was your thoughts on direct air capture and even direct air capture from the most unlikely of places. Tell everyone what we were talking about that day.
It is possible that these units, specifically the KMCDR process, can be operated in a way and can be designed in a way to allow them to be net negative. Basically, you're capturing CO2 not just at 90 or 95%, but something like 99.5%. And we recently at GHGT presented some test results that we've done to validate that and to back it up.
Yeah, so this makes an interesting point. You're also capturing the CO2 that's in the air in the combustion process, right?
Right. Yeah. So you get some amount of CO2 that comes in with your combustion air. Ultimately, that plus the amount of CO2 that you generate from combustion, you want what's coming out of your stack to be less than that overall, right? And then you're considered technically for, depending on how you draw your boundary, net negative.
Right. One of the questions that we got was, and this can go for everyone, which is what percentage of existing coal plants are expected to make these conversions? Any predictions? And look, I would say you're aware of all the coal plants that are there on the system. You've probably looked at all of them and said, okay, what would it take for CO2 capture? What would it take to get a gas retrofit there? What would it take to load follow? I think you already have an idea about what plants are best for these sorts of retrofits or repowers already, right?
So from our perspective, we generally say newer units that have environmental controls, I would say full AQCS, because there are some constituents in the flue gas that we would prefer to have lower coming into the CO2 unit, some things that elevate amine losses and increase the operating costs over time. We'd like to target newer units that have full air quality control systems installed on them.
There's a good point Jared's made that if the coal facility has already gone through all the different environmental controls that needed to be added to it to remain in the fleet, then it's really a matter of, okay, are we extending the life? And I got a couple options. I could fully repower, or I could do the conversion and just reuse the boiler. But still, I'd say that maybe a third to a half that really just go through decommissioning and eventually either abandoned in place or demolition at some point. There's still a high percentage that will get there just based on the economics of the facility.
Yeah, and just to add to that, and you asked what would it take for these plants to convert, and I think what it takes first and foremost is a price on carbon or CO2 emissions, one way or the other. If you want to talk carbon tax or a clean energy standard or some kind of form on that where you're really limited as to what your options are going forward, because right now, if you don't put a price on carbon, your cheapest option is still to go with a new natural gas combined cycle plant. This is really designed for these flexible operations, but once you take the new natural gas step out of it, because you're trying to reduce your CO2 emissions or go to 100% clean energy standard by 2035, like the president is currently talking about, you have to make do with what you currently have on the system. And that's what we're really talking about here. How can we still provide a reliable electric grid that includes fuel diversity and that includes coal to some extent, but making it neutral in some shape or form. And so I think a carbon program is really what it takes for plants to convert.
This is also for everyone. Tell us about the financing involved in retrofitting or repowering coal plants like these. Wind has massive government incentives to repower old turbines, for instance. We discussed that on the panel I did in episode 110. Should coal plants get the same? What's really out there to incentivize it?
So from the carbon capture perspective, at least in the United States, the big incentive now is the 45Q tax credit. The way that it's structured, what you really need is financing institution or a financing source that has some tax equity interest, right? Because although Biden in his infrastructure plan is proposing to make this direct pay, it's not currently laid out that way. You really need to have a source that has some tax equity interest, some tax to offset with these credits.
Yeah, and on a financial side, again, if we're talking, like I said, over the last year or so, we've talked to a lot of regulated utility commissioners. Obviously, the financing is a little different than the merchant plant, but it's really for utilities to even consider these plants, even though there might be higher cost, but have a higher focus on reliability and diversity instead of just going with a tagline of I've retired X coal-fired power plants in order to achieve decarbonization goals is really key. So I think having a fuel diverse grid can potentially cost more, but I think it's, as we have seen this year in Texas and the Midwest, it's really key to keeping the lights on.
Yeah, and then the final question, I think Philip brought this up in a big way, a lot more downtime. You're no longer baseload. You have to, quote, live on the margins after that. How viable is that for a lot of what would be non-traditional coal plants, and what are some ways that they can lean out and continue to operate?
I always like to compare it to a car that I have, right? Or right now, let's say this is a 20-year-old Toyota Camry and stuff, and it runs fine, but higher fuel efficiency standards will require me to have a higher miles per gallon. I could buy a new car now that gets me 30 miles a gallon or 40 miles a gallon, or I can try to run my car for another 5 or 10 years until electric vehicles or fuel cell vehicles or whatever actually become more cost efficient than this new 40 miles per gallon car. I think the key is not to extend the lives of coal plants indefinitely, but really until we have the technology, be it on the energy storage side, that allows us to operate the grid in a reliable and effective way, how we're doing it currently with fossil fuel plants.
You can get into more of that peaker mode with an existing facility, and you're extending the life of generating power. But I think to Philip's point, it's hard to see the viability of extending the life of the coal facility very long term. It's switching fuel, getting what you can out of that existing asset, and to Philip's analogy, not having to buy a whole new car. Because if you start to look at buying a whole new car, then, okay, do you want to reuse the whole site, repower? Do you want to do something completely different? And even in those situations, you can bring in renewables. There's a lot of land around a facility. You can put in solar PV as a part of that solution. You can start to think of the future of, okay, what's green hydrogen bringing to play on these things? So you got to first think about, where do I want to go with it? Do I just need to match my load profile? Can I switch fuel? What can I do? Just those early options, or do I need to think bigger about it?
All right, that'll do it. We're out of time. Again, this has been a great opportunity with wonderful guests today to talk about the possible solutions we have out there. Thank you very much. That was my panel from the PowerGen Plus series, Converting a Coal-Fired Plant, Benefits and Challenges. I want to thank my three panelists for their time as well as their communications teams, and of course the folks at PowerGen for giving us such a great platform to share ideas. You can find plenty of pictures as well as the presentations for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 116. Be sure to join us next week when we check in on the latest developments from the Department of Energy on that most reliable of renewable energy sources, geothermal. Until then, I'm Jay Downhauer. We'll see you next time.